So in section 6.3 here, we're going to look at the natural exponential function. So remember that ln of x is 1 to 1, and why would that be? Remember that if you graph y equals ln of x, it looks like this. And notice that that's an increasing function, and increasing or decreasing functions are 1 to 1. So since it's 1 to 1, it has an inverse. We're going to call that inverse y equals exp of x. So that's going to be the exponential, natural exponential function. And the equivalent logarithmic statement here is that ln of y is equal x. So right, our input x is our output here, and our output y is our input here. Well, if this is the inverse, then the cancellation laws have to work. So if you do the exponential of ln of x, you should get x back again. Or if you do ln of exp of x, you should get x, both orders. In particular, if you do exp of 0, you have to get 1. And that's because log of 1 is equal to 0. And exp of 1 has to equal the number e, the base for the natural logarithm. And that's because ln of e is equal to 1. So that's just using this statement. And then further, if you do the natural log of e to the r, well, inside exponents factor down. So that's r times ln of e. And then ln of e is equal to 1. So that's equal to r. So this is saying if you start with r, do e to the r, and then do the natural log, you get back r again. So that's saying that they cancel in that order. That's saying that if we go up here, ln of exp of x has to be equal to x, and here we did ln of e to the r for rational numbers has to be r. So that means that this exp here and then e to the x have to be the same function for rationals. But if they're the same for rationals, then they actually have to be the same for all real x. So this exponential function that we're looking for is actually e to the x. So that's the natural exponential. That's the inverse of the natural logarithm. So here's our definition of the natural exponential. Y equals e to the x is defined by ln of y equals x. So they're inverses. So they're defined by being inverses of each other. And then because of that, we have our cancellation laws, which are first, if you take the natural log of e to the x, you get x. And secondly, if you do e to the ln of x, you get x. Now this one, this is for x not equal, well actually for x greater than 0 here, because you can't put negatives into the log. And e to the x is always positive, so this part's okay. So this is for all reals and this is for positive reals. So those are our two cancellation laws. If you start with x, do an exponential, do a natural log, get x back again. Start with x, do a natural log, do e to the x, get x back again. So that's going to let us simplify expressions that involve both exponentials and logs. So for example here, e to the negative 2 ln 3, well this negative 2 exponent outside the log will come up on top. So this is e to the ln of 3 to the negative 2. And then e and ln cancel each other. That's this cancellation law. So that's 3 to the negative 2, which is 1 over 3 squared, which is 1/9. And then let's look at one the other way. If we do natural log of e to the 4x, ln and e will cancel each other. We get 4x. So when exponentials and logs occur together inside an expression, you can use your cancellation laws to simplify.